Factor by grouping. 15x to the sixth minus 10x to the third minus 9x to the third plus 6. Okay, what we're really being asked to do here is to factor a polynomial. Well, to factor anything, let's just take a step back for a second. When we're being asked to factor some expression or polynomial in this case, when we're being asked to factor, our goal ultimately is to take the expression that we're being given and express it as a multiplication expression. So what we're looking at is, let's write it out. We're looking at 15x to the sixth minus 10x to the third minus 9x to the third plus 6. We're looking at an algebraic expression at the very least, but it rises to the level of being called a polynomial because the exponents on the variables are whole numbers. So this is a polynomial. Now, when we're factoring a polynomial, which is really a collection, let's break it down just a little bit further. A polynomial is a collection of terms. There's one term. Terms are in a polynomial are connected with add and subtract. So we're looking at that this is the sum of, even though we have subtraction in a couple of places, this is the sum of terms where the variables have whole numbers. This is a polynomial of 4 terms. It's a 4-term polynomial. The first step in trying to factor and turn, it's kind of like the odd part of the abstract part for students is you're essentially taking addition and subtraction expression, in this case a polynomial, and you're turning it into a pure multiplication expression. So there's got to be a process that we follow because it's a little bit abstract. The first step in factoring a polynomial, or trying to, is to find the GCF, the greatest common factor. And we look for, within each term, we look for factors that each term may have in common. The first easiest factor to include or exclude are variables. I see that the variable x appears in each of the first 3 terms, but x does not appear in the constant. Therefore, I would not include x in the GCF because it's not in common across all 4 terms. There's not an x in this last constant term of 6. So now we can focus our attention on the numbers. 15 is 3 times 5. 10 is 2 times 5. I'm factoring. 9 is 3 times 3. And 6 is 2 times 3. So we're looking now. We're down to just prime numbers, factoring, prime factorization of the constants, the coefficients of this polynomial. 3. Is there a factor of 3 in every term? Almost. 3 is in the first term and the last 2, but not in the second. Okay, let's look for 5. 5 is in the first 2 terms. Factor of 5 is in common with the first 2 terms, but 5 doesn't appear in the last 2. And then, 2. 2 appears in the second and the fourth terms, but not the first or second. So at this point, I would say, well, there are no common factors across these all 4 terms, except 1 and -1. 1 is always in common with every term. So when you don't find something greater than 1, we can always say the GCF is positive or -1. But it doesn't really help us. To say something times 1 isn't true factoring in the sense that we would choose, if that's all we could find, we would call the polynomial prime. But we can't stop here. We need to look a little bit further and see if we can factor this even without finding a GCF. I'm going to write a clean copy. 15x to the 6 minus 10x to the third minus 9x to the third plus 6. This is a clean copy of our original polynomial. So here's the thing. Once, when we try to factor out the GCF, it's really our first method of factoring, where we try to make a multiplication expression in the most basic way, but when it doesn't help us, we have to proceed. We have to proceed to looking for another method. Now, if we ask ourselves, is this a 4-term polynomial? The answer is yes. We counted them in the beginning. And when you say yes to that it's a 4-term polynomial, the idea is to try factor by grouping, which is built into this instruction for our problem. So here's what factor by grouping is. We may not have had a GCF other than one, a useful GCF across all 4 terms, but perhaps we have a common factor between the first 2 terms that perhaps we could pull out. So I'm going to look now, we're going to look for a factor that we might have in common with the first 2 terms. And sure enough, we said before, x is an easy, variables are easy to identify and include in a common factor. So x is definitely in common with both of the first 2 terms. How many? Well, the smallest exponent limits the total number of matchups, for common factors. So we're going to take an x to the third out of each of these 2 terms as a common factor. And also, if I'm using our factor trees from up above, we see that there's also a factor of 5 in common. So we can take out a total of 5x to the third power from these first 2 terms. So let's look at leaving here a remaining polynomial where the first term we always want to be positive. We're going to multiply 5x to the third power. We're going to use the GCF as positive to make this term come back. What would we need to put in this blank so that positive 15x to the 6th comes back? Well, positive times positive is positive. Good. Numbers now, 5 times 3 makes 15. X to the third times, I need another x to the third so that the product rule for exponents, x to the third times x to the third, the 3 and the 3 add to make 6. So when we're filling in these blanks, we are accounting for, we're using the product rule for exponents. When the bases are the same, we add exponents to make sure that we cover make sure to recover the proper exponent for what we're trying to make come back right above here. Okay, next, we're trying to make this term come back. What would we need in this blank if we take the GCF and distribute to this blank? Positive times negative to make this negative come back. Then 5, moving on to numbers, 5 times I need a 2 to make 10. But look, see this whole x to the third? We already have that in the GCF. We don't need any more x's here. Okay, next thing. I teach my students to take this first binomial and copy it. Just copy it right underneath the last 2 terms that we're trying to make come back. 3x to the third minus 2. We're copying this remaining polynomial right underneath the last 2 terms, and we're going to analyze what would we need to put in this blank, what would we need to put in that blank, so that this times this makes this come back right above it. What would we need? Signs, numbers, variables, anything we need to put in this red blank. Well, this 3x cubed is positive, so we definitely need a negative times this positive to make negative. Then we need a 3 times 3 to make 9, and the x cubed is already in this blank, so we don't need any more x's in this red blank. Now, we have to continue distributing this negative 3 to see if it works to make this positive 6 comes back. So does it? Negative 3 times negative 2. Negative times negative makes positive, and 3 times 2 makes 6. It's working. Okay, here's what we have. At this point, what we're finding out is we actually do have a GCF in this big polynomial. The GCF actually is 3x cubed minus 2. And when we write it out, 3x cubed, whenever we find a GCF, we write it out once. We've made several points about that. 3x cubed minus 2. This is the GCF. And what we need is another kind of remaining polynomial now where 3x cubed minus 2 would make all of this, when we distribute this to this blank, what would we need here to make all of this first big term come back? Well, we need the 5x cubed. 5x cubed. And when we distribute this whole green GCF to the second blank to make all of this second big term come back, what would we need? Like, here's the 3x cubed minus 2 factor right here. What's missing? The negative 3, or just minus 3. Okay, so I believe we've accomplished factoring. What we should do to make sure, always take your factors and check them. Okay, so if we make a check step, let's make a check step. Let's check our factors. You should always be able to take your factors and check them to make sure they're correct. In a single color, 3x cubed minus 2, there's our GCF, our big GCF that we ended up finding. And then here's our remaining polynomial at the end, 5x cubed minus 3. And let's just FOIL these. Let's FOIL them, see if they're right. See if if we FOIL these, we should be able to get our original 4 terms back. So let's see what happens here. F in FOIL is positive times positive is positive. 3 times 5 is 15. X to the third times x to the third. We add exponents by the product rule again. X to the sixth. Outer. Negative times negative 3 times positive 3 is negative 9. Here's the outer. Negative 9. X to the third. Here's the inner. The inner would be these two guys. Negative times positive is negative. 2 times 5 is 10, x to the third. And the last partial product would be negative 2 times negative 3 is positive 6. So let's check these against our original polynomial. In our original polynomial, do we have a 15x to the sixth? Yes, we do. We got this term back. This O term, negative 9x to the third, do we have that? Negative 9x to the third, yes. And we could make it these appear in the original order if we apply the commutative property of addition. No problem. We just need to make sure that they're all here. The I partial product gave us a negative 10x to the third. Do we have that in the original? Yes, we do. We're getting all these terms back. And then our last partial product is a positive 6. And sure enough, here's a positive 6. So we have checked that our factors are correct, and they are correct. So we're looking now for which of the answer choices have the factors that we've found. Now, mark this in mind. The times dot, the multiplication appears between these two factors. I could see these factors in this order, or we could rotate them around that times dot. We could see in the answer choices 5x to the third minus 3 times, and as the second factor, we could then see this green factor, 3x cubed minus 2. Because two things multiplied this way, if we rotate them around, they equal the same thing. They produce the same result when they're rotated around the times dot. Just as 2 times 3 is 6, the same as 3 times 2 is 6. So let's see if which answers have our factors in them. Okay, we're looking for 5x minus 3. Looking for a factor of 5x minus 3. Which ones have answers of factors of 5x cubed minus 3? 5x cubed minus 3. I only see it in D, this factor. Now, which answers have 3x cubed minus 2? 3x cubed minus 2 is right here. The only answer that has both correct factors, let me check again, 5x cubed minus 3 times 3x cubed minus 2. Yes. The only answer that has the correct factors in it is answer D. So we've completed our test, our exam, wherever this question is appearing. The final thing you need to do is choose the correct response is D.